The first video on trig graphs introduced the graphs of the sine and cosine functions. Here is y equals sine x. Starting at the origin, it oscillates around the x-axis, peaking at 1, dipping to -1, and at 360 degrees it's completed a cycle. That's the period, because it just repeats itself in the next 360 degrees and so on. Cosine curve is in fact the same curve, simply it's a sine graph shifted 90 degrees to the left. So it's also got a period of 360 degrees and a maximum value 1 and a minimum value -1. If you take angles that add up to 90 degrees, they are complementary angles, like 30 degrees and 60 degrees. So for example, cos 60 degrees is a half. Sine 30 degrees is also a half, they are equal. The same would be true, say, for sine 20, cos 70. As long as the two angles add up to 90 degrees, that's are complementary, the sine of the complement and the cos of the other angle will be equal. So cosine means the complement of the sine. We're interested in the interval between 0 and 360 degrees, that's one cycle, where it peaks at 1 and dips to its minimum -1, and where it hits the x-axis. Same with the cosine graph. So these key points here are important when you carry out graph transformations. We want to know what happens to these points, as we want to know their images. We want to know the coordinates of the images under the transformation. In the second video, there were two transformations. One was where you changed the x coordinate, the input to the function, and the other where you changed sine x, the output. So these graphs have to be memorised, these key positions. A function has an input, you input an angle, out comes a value, which is opposite over hypotenuse. So input x, output all of sine x. If you change x, say by multiplying it by a number, that will affect the x coordinates of the graph. If you take sine x and you say multiply it by a number, you'll affect the y coordinates, the output. Because when we draw a graph, the graph is angle x degrees, that's the input to the function, and the y coordinate is the sine x, that's the output. So there's an input and there's an output. The y coordinate is the output. So it's a case of if you affect the y coordinate or do you affect the x coordinate. Second video had graph transformations, which we need for this video as well. So here is y equals sine x. If I put a number in front of sine x, all of sine x is the y coordinate. I've just multiplied it by 3. At 90 degrees, the y coordinate is 1. The y coordinate is now 3 times bigger. So it's still 90 degrees, but it's 3. At 270 degrees, the value is -1. So the y coordinate is -1. Multiplied by 3, it becomes -3. But it's still at 270 degrees. Here, at these positions on the x-axis, the y coordinates are, there we go, the y coordinates are 0. You multiply the y coordinate by 3, it's still 0. So that's why they stayed still, they didn't change at all. That's 0, 0, 180, 0, 360, 0. So the y coordinate is 0, they're fixed. If you have the curve nailed down there, and it was made of elastic, you're stretching it up and stretching it down. So that's called a y stretch. You do this similar thing for the cosine. So that was one change. A second change we looked at in the second video was if you put a number in front of x. This is affecting the input. You're doubling up x. Now that means, since you're doubling x up, you can put in for x half of what you used to. So for example, at 90 degrees, we got the peak of 1. So at 90 degrees, it peaked. Now we can say, make x 45, because double 45 is 90. So we can put in 45 in order to get 90 in the brackets. So if we want what happened at 90 degrees, half that, 45 degrees, is what you input for x. the x-coordinates halved. 90 halved to 45. At 270 degrees it went to its minimum. It now gets its minimum at half of that, 135. You put in 135 in place of x, it will double up to the 270. Similarly, that 180 degrees got half to 90. Or the whole period of the sine x graph here dotted was 360. The period's half to 180. So all the x coordinates are halved. All the angles have been halved. So that was the second change. This is the third change. If we take this curve and I slide it up, so I've slid it up 5, so what I'm going to do is just bring this down so it can be seen. So everything just is going to slide up 5. There we go. And I'll need to adjust the axes here for the interval. There we go. Now what's happened here is sine x is a y coordinate and it gained 5. So at 90 degrees the y coordinate was 1. It just gained 5 to become 6. At 270 degrees the y coordinate had been negative 1. It just gained 5 to become 4. At 0, 180 and 360 the y coordinate was 0. They gained 5 to become 0, 5. 180 degrees, 5. 360 degrees, 5. Everything slid 5 up. Sine x is a y coordinate, they all gained 5. X coordinates are unchanged. Of course, you could take it down 5. There it is. Y coordinates lose 5. So at 90 degrees the y coordinate was 1. It loses 5 to become negative 4. At 270 degrees the y coordinate was negative 1. It loses 5 to become negative 6. At 0, 180 and 360 the y coordinate was 0. They lose 5. This is 0, negative 5. 180, negative 5. 360, negative 5. The graph oscillates around this dotted line, which is a line y equals 5. That's 3 changes we can now make, so we can combine them. There's a y stretch of 3. The y coordinates are multiplied by 3, so we had that before. Second change, which I had before, this is 3 sine 2x, so the x coordinates got halved. Used to peak at 90 degrees, and now peaks at 45. Used to go to its minimum at 270 degrees, and now goes to its minimum at 135. It halved all the x coordinates. So these were in the second video. The bit we've got now is, and again I'll bring this down slightly, we can now slide it. I'll slide it up the 5 it was before, and there it is, it's slid up 5. Now what's happened is, every y coordinate's gained 5, and that slid it 5 up. Now, if you examine this curve here, you can see the period is 180. That's because of that 2x. You can see it oscillates 5 up, all around a line y equals 5. That's that plus 5 in the end. And from that dotted line y equals 5, it's going 3 up to its peak 8. So from this dotted line being y equals 5, it's become y coordinate 8. That's a difference of 3. In other words, there's 3 units here. That's the amplitude of the graph, 3. It's this 3. It goes 3 above the dotted line and 3 below the dotted line. So that's the 3 changes. This is the period halved. This sine 2x is all the y coordinates. They get multiplied by 3 and 5 added. So at 90 degrees when it was 1, you take 1 and you multiply it by 3 and add 5 and it becomes 8. You take 270 degrees here where it went down to negative 1, so you take the negative 1, you multiply it by 3 and you add 5 and that gives you 2. So 3 times the y coordinate add 5 changes the y coordinates. Halving, dividing by 2 the x coordinates for this part in the brackets. So that's the 3 changes. They'll be in a worksheet with examples to practice on. If you click the link in the description, it takes to a Google Drive but there's PDFs which are practice questions with answers. Cosine, if I apply the same sort of changes, it'll just have the same sort of effect. That's a y stretch, the y coordinates are multiplied by 3. Now, it usually went to a minimum -1. There is a minimum -3 now. The y coordinate has been multiplied by 3. That 2x just halved all the x coordinates. The period is halved to 180. So there's one cycle in 180, 2 cycles in 360. And that was in the second video with worksheets. So applying the third change, it's now slid up 5. So this plus 5 is because it's oscillating around this dotted line, which is 5 up. It used to be at a minimum at 180 degrees, it's now at a minimum of 90. So the 180 has been halved because of that 2x. This is just the same as the sine curve. And the 3 is just for the same reason. There's a line y equals 5, you go 3 above it to 8, and 3 below it to 2. So this is just like 3 sine 2x plus 5. It was just, it happens at different x coordinates. There they are compared. Basically, slide the red curve to the left and it gives you the blue curve. They're just it's happening at slightly different places. So that's the changes. We'd like to know the 5 positions. This position 05, this position 45.8, this position 95, this position 1352, and this position 185. Now, one of the worksheets will have certain examples on it of this type. If you use the first video, there were 12 questions in a worksheet using y equals a sine bx. There's another 12 questions using this type of arrangement, y equals a sine bx plus c, and of course the cosine case. You fill in completing the axis here with the angles. These are quarters there, so 120 halves to 60, which halves to 30, then 30-degree intervals. You have to get the maximum and minimum turning points, which you can now read off. 30 degrees, 12, and 90 degrees, 4. So that's the maximum here, and the minimum here. So that's the maximum and minimum. Because of this 120 degrees, 3 times 120 makes 360. That tells you that b is 3x here. It's oscillating around a line in the middle here. To get that line, peaks at 12, goes to its minimum at 4. This is halfway position. 12 plus 4 is 16 and a half, it's 8. That is a line y equals 8. Halfway between 12 and 4, add 12 and 4 and a half. That's the C. The whole thing is a graph slid 8 up, because it normally oscillates around the x-axis. And finally, A is from 8 to 12 is 4 units. That amplitude is 4. It goes 4 above the dotted line and 4 below the dotted line. So A is 4. Filling that in, we get this. 3x, that was the period 120 degrees. The plus 8, that was this dotted line, 8 up. And the 4 was the fact it went 4 above the dotted line and 4 below the dotted line. If we do it for cosine, same business. There's 60 degrees, halfway's 30, half of that's 15. There's the axis filled in. Now the peak's at 17, that's at 0, 17. And here's the minimum value 3, that's at 30 degrees 3. So that fills in maximum, minimum. And the equation comes from, we need to get C. It's halfway between 17 and 3. 17 and 3 is 20. Half it's 10. So that's a halfway position between the 17 and the 3. The line y equals 10. That's the C's 10. And for A, it's 7 above 10 and 7 below 10. So the curve oscillates 7 above 10, to 7 below 10. So that gap there, the amplitude is 7, that's the A. So there's the equation. So there'll be a worksheet on that, and the questions you'll do in the worksheet is, on this worksheet, it's after question 12, up to question 12 is for the second video. So for this, it's questions 13 to 24. There we go. There they are. 13 starts there. On to 24, and the answers are at the back. For this booklet, the first 18 questions were for the second video. That's the type y equals a sine bx, a cos bx. And then if you go to question 25, this is the new stuff where there's 3 changes. This is y equals a sine bx plus c from 25 to 33. And the answers are at the back. As well as that, there's a set of notes to download which covers all the videos in Trig graphs. These questions there at the end are like the ones you've just seen. There's still one transformation to go, the 4th transformation, and it's also in the notes there, but that'll be in the next video. Hope this video has